applications. So we have to apply our knowledge of calculus now. When you look through a paper, when you find paper 1 that you're going through all the motions, then you see the equations and inequalities, then we get to the number pattern sequences and series, then you get to the parabolas, hyperbolas, etc. Then you get to your financial maths. Just after financial maths, you get to calculus. And after calculus, probability. You should know kind of like this. Sometimes they swap the financial maths somewhere else, but in general, that's the way that the order of the paper goes. But in the calculus department, they start off using, first of all, first principles. Second one, the shortcut method. Then there's normally something about a tangent to the graph and what's the equation of the tangent. Then we'll get into our next, that's the first question. The second question will be something about the graphs, the cubic graphs, sketching them or finding their equations, something in the line of that. That second push question paper has got the derivative graph in it, which I said to you, they don't always ask that it's got the derivative graph in it. And then the last question on calculus is the application, which will be the last question, which will be about 7-8 marks. Sometimes a little bit more, but in general it's about 7-8 marks. So the question will be something like, I give you a sketch and I ask you to work out area, volume. This is the place where they actually test you on what you've been taught from primary school on volumes and surface area. So you could be able to work out the volume and the surface area by looking at a graph or a sketch or whatever they've given you. Then they say, please find me the area. So you've got to know flat figures, the triangles, areas, half base, times perpendicular height. Or I give you a cube, or I give you a cylinder, or whatever. You've got to be able to work out those volumes and surface areas. Can you still remember them? And then I will ask you for whatever that was that you worked out, for the minimum or maximum value. So normally if I ask you to work out the area, I'll ask you for maximum area. If I ask you to work out the volume, I'm going to ask you for maximum volume. If there was another type of sum where you didn't have to actually work it out yourself, but I'm saying to work out the distance from here to the labs, here's a formula. They give you the formula, that's fantastic, so you can't make a mistake in getting the formula yourself. But then with that formula, I'll say the distance is worked out with this thing, find me the maximum distance. So you take that distance formula, and for maximum, like always, you do the derivative, and you put it equal to
0.
Because it was always equal to 0, because when you're looking for maximum whatever, on the graph that represents that scenario, you'll get the maximum and the minimum by always doing derivative equal to 0. Do we always put every derivative equal to 0? No, because the derivative gives you the gradient, and from point to point the gradient can change. So that's fine. But when you're busy with max and min, you've got to know that that means your turning point is where the gradient is equal to 0. Other stuff that can be applied here is if they ask you speed, the other word for speed is velocity, just know all your synonyms. And then something as well that they do like, rate of change, tempo of change. Can you see it being something to do with the speed of change? Still coming back to the derivative, it's something you've got to teach yourself. So if they talk of the tempo of change or the tempo at which something changes, or the rate at which something changes. Do you see it being a speed at which something changes? Speed being derivative. Then acceleration doesn't get asked a lot, but if it does, you should know that that is double derivative when it appears. So let's have a look at this example. The example said, we've got a flat figure here, which is a triangle, and they're giving me the two sides in terms of x, and the first question says, please give me a formula of the area in terms of x. So easy peasy, lemon squeezy, we've got area is equal to half base times perpendicular. Which one is the base and which one is the height? It doesn't matter. Because when you swap that thing around, we always want to say that this is the base. It doesn't have to be. You can flip this and that can be the base and the perpendicular. Right? And it doesn't matter if I swap them around. So then I first, now if the question is said, find the area in terms of x, I'm done.
Okay.
But you know that you're in calculus. And you know if all else fails and you're not lacquer on the sum, you should be deriving. Don't know what they want from me, but I'm deriving. Please, can I teach you that? You don't know what else to do, at least derive. Can you derive this? No, you've got to first distribute and get the answer, and then you can derive. So to derive, I've got to do my FOIL, which is going to give me 32 minus 4 and plus 8 is going to give me 4x. Minus times a minus is a minus. Minus times a plus is a minus. And then to get to the answer would be half of 32 is 16. Half of 4 gives me 2x. And then this would be a half x squared. What kind of a function is this? What does it represent if I have to go to graphs? Always think graphs. This is a parabola. It's just backwards. Please don't make trouble for yourself. Leave it like that, but you know that it's a parabola. Or what type of parabola? A frowny face. So the next question will ask me, for which value of x will this be a maximum? Maximum. This is representing area, and there will be a maximum at the turning point. But the main thing to realize is when you read the word maximum, maximum area, then you go take the area formula and you derive and put it equal to 0. If it was a distance formula and you want maximum distance, distance formula derived equal to 0. It's a pattern that you've got to see there. So for maximum area, you've got to take the area. Now there's a few things I'd like to talk about. Most of the time they just use it like this with a equals. Ma'am likes to say ax. So that looks like the function fx in terms of x, but if you don't have it there, it's fine. So that over here I can speak about the derivative. And if I don't have the x there, because they do that, they just write a or s or whatever without the x's there, you don't have to put it in there, just so that you know. So I'm deriving, and why am I putting it equal to 0? Because for a maximum of this parabola, I've got to take the derivative and put it equal to 0. So if all else fails and you're not quite sure what they're asking you, you derive and put it equal to 0. Okay, hopefully you got a mark or two. But then I had to time it out so that I can get the derivative. So whether I time it out there, or I've got to time it out here now, somewhere I've got to time it out. So what's the derivative, please? 0 plus 2. 2 times minus a half is minus 1. X to the 1. And it's equal to 0. See again? 2 times minus a half is minus 1. Take 1 away. Agree with me that that is the derivative. Equal to 0 because I'm looking where it's turning. That's where the max is going to be. And then my answer for x would be equal to 2. What was the question? Find the value of x for which the area will be a max. So what's the maximum area? 2. Not 2. Where's the area formula? There's the area formula. And I only know that it will have a max for x equal to 2. That's why the next question came and they said, find me the maximum area. So you've got to know to go back to that formula and substitute that x with a, so it's going to give you 16 plus 2x minus a half x, which is 2 squared again, and giving me an answer of, could I not have gone there and put my 2 there in the place of x? Because all of these are equivalent to each other, so it doesn't matter which one you go put it, and you're going to get an answer of, please?
18.
Yeah? 18. 18 what? Because now if you read the question there, I think they said that this is, no, they didn't say. But sometimes they will say this is in meters. So this answer is now the area in square meters. If they don't say anything, I like it if you say
Units squared. Square units. Units squared.
or square units or whatever. And if you don't write anything, that's also okay. But normally what they do is they say it's in kilometers, so your answer is in kilometers squared. Or if it's volume and they say that the distances, the units were in meters, so for volume it'll be cubic meters. That's not going to cost you any marks. Okay.
Guys.